Hello everybody. Today we'll be going through question 198, house robber. So for this question, you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected and it will automatically contact the police if two adjacent houses were broken into on the same night. So given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. Let's take a look at the example input for example 1. So given an integer array of 1, 2, 3, and 1, the maximum amount of money that the robber is able to rob is $4. So this is because for the first house, he's able to get $1, and he's unable to rob the next house because it's adjacent to the first house. So he moves on to the next house, which is he's able to rob $3, and then moving on, he's unable to rob the fourth house. So the total amount that he's able to get is actually $1 plus $3, which is $4. So let's look at the inputs again. We have house 1, which has $1. We have house 2, which has $2, house 3 has $3, and house 4 has $1. So if the robber chooses to rob house 1, he will be unable to rob the adjacent house, which is house 2. So the total he has now is $1. He moves on to this next house, he's unable to rob it, so he moves on to the third house. He's able to rob it because he didn't rob house 2. So he picks this one, and now the total will be $3. And he moves on to the next house, and he's unable to rob this, and so the total amount of money he is able to rob is $4. So this is scenario 1. The next scenario is scenario 2. So we have the same input 1, 2, 3, and 4. For the next scenario, the robber can choose not to rob house 1. So the total, he didn't choose house 1, he didn't get any money, but he can choose to rob house 2. So he gets $2. And because he can't rob the adjacent house, so he will skip house 3, and then for house 4, he can choose to rob it. So the total amount he gets is $3. Add one more scenario. So scenario 3, we got the same inputs. Scenario 3 is he doesn't rob house 1, he doesn't rob house 2, but he robs house 3, and because he robs house 3, he's not able to rob the fourth house. So the total he's able to get is just $3. So as you can see, there's many different permutations of whether he chooses to rob a house or he does not choose to rob a house, but he has to follow the rule that if he chooses to rob a house, he's unable to rob the adjacent houses beside it. So based on those information, we are able to come up with the dynamic programming formula. But first, we need to see the robber's options. For option 1, he is able to rob the house and unable to rob the house, the previous house, or the next house. And for option 2 is he does not rob the house but is able to rob the next house or previous house. So based on this, we can actually have a dp of I equals to the math.max of he chooses to rob the house, and he will be able to get the money from not the adjacent one, but the house before the adjacent one, or he just robs the previous house. So this is actually the DP formula. Now let's code out the problem. If nums.length equals to 0, we can actually return 0 because there's no house to rob. And now we can look through all the options for int I equals to 0 and I less than nums.length and I plus plus. If I equals to 0, we can skip it. Else, if I equals to 1, we can set nums of I equals to math.max nums I, or nums I minus 1. So if the index is 1, we can choose to actually rob the house, or we choose to rob the previous house. We see which is the house that gives us the max money, and then we set it in our DP table. This is for the second case. And the last case, we need to use our DP formula. So for nums I, we can choose the math.max of nums I plus nums I minus 2. So we can't rob the previous house, but we can rob the house before the previous house. So we need to minus 2 from here. Or we can choose not to rob the house, and so we just choose the maximum of the previous house. And after that, we can just return the last index. So let's run our code. And we'll submit. So our code has succeeded. And that's how you solve the house robber problem.